30, 60, 90 triangle. All right. So when looking at this, I think we obviously don't need to know the properties of 30, 60, 90 triangles. For most problems, you can obviously go back and revert to using trig, sine, cosine, and tangent. However, it is very, very, very helpful to make sure that you understand the relationships when you have a right triangle that has the other two angles as 60 degrees and 30 degrees. All right? And that's why we call it a special right triangle. Amy, if you could turn your desk 90 degrees. Or you want to sit like that? That's OK? OK. For Tansy, do you want to turn yours the other way? You can turn it 90 degrees so it's easier to look over.
I'll still work it.
Huh? OK. Well, I just wanted to see if you can, if that's comfortable for you, that's OK. But I know it might be easier just to turn your desk. So the relationship for the 30, 60, 90, I know we've already done a problem like this, but the relationship is, let's pretend our short leg, we have two legs, hypotenuse, short leg, long leg. Let's just pretend the short leg has a value of x. It could be 1, it could be 2, but let's just say it represents any number. The relationship for a 30, 60, 90 triangle of the short leg to the hypotenuse is twice the size, or 2x. Then the relationship from the short leg to the long leg is x square root of 3. OK? Now, this isn't part of the problem, but the other special triangle is the 45, 45 triangle, 45, 45, 90 triangle. All right? And just because I figured this might be helpful for you guys, if you do not remember the relationship, if you have one of the legs on a 45, 45, that's an isosceles right triangle. So the two legs are the same. And the hypotenuse is x square root of 2. All right? So we're going to use this information, not the 45, 45. I just wanted to teach you that. But we're going to use the information for the 30, 60, 90 triangle to go ahead and solve for this one. Yes?
I thought you used square root on the hypotenuse.
Huh?
I thought the long leg was 2x.
Nope. No, it's the hypotenuse is 2x. So now the important thing is they're talking about we have a 30, 60, 90 triangle when the length of the longer leg is 12 inches. Yes?
Isn't the hypotenuse the longer?
Remember, this is always the hypotenuse. So when you have a right triangle, you have a leg, and the hypotenuse. So these are the two legs. We have the short leg and the long leg on this one. See here, the two legs are equal. Here, we call this short leg, long leg, and that hypotenuse is always directly across, right? Right. So it's a little bit different than the 45. So when you're coloring in your C, and what we need to do is identify what is then going to be the relationship if, let's say, 60, 30 degrees, and they say the longer leg is 12 inches, which is right there. So let's go and think about this. The way that I taught it is that the short leg is x. To go to the hypotenuse, you multiply by 2. If the short leg is x, to get to the long leg, you'd multiply by square root of 3. But now we say the long leg is 12. So how would I figure, to go from short leg to long leg, you multiply by square root of 3. So to go from long leg to short leg, you'd have to divide by square root of 3. So would it make sense that I could say the short leg then is 12 divided by the square root of 3? Would that make sense? No? So for instance, what if I said this was 3? This would be 3 square root of 3, right? Whatever the short leg is, you multiply by the square root of 3. Does that make sense? To go from short to long leg. So therefore, if I gave you this, and I say, what is that? Well, then you're going to have to divide by square root of 3. Does it make sense? And then that would cancel out, and that's why you get 3. So I gave you 12. So to go back, you would have to divide by the square root of 3. OK? Now, to go from the hypotenuse, George, what do you have to do? To go from the short leg to the hypotenuse, you have to multiply by 2. So I can write this. 2 times 12 over square root of 3. Make sense? Yes? Now, why do I keep on asking you guys to restate the question, restate the question, restate the question? So you understand and you make sure you answer the question and check your answer. It says, what is the perimeter? It doesn't say what is the length of one of the sides. So the perimeter, so hopefully, again, you guys remember that the perimeter is just the distance all the way around the circle, all the way around the triangle. So I can do 2 times 12 is 24. So I have 24 over square root of 3 plus 12 over square root of 3 plus 12 equals my perimeter. Would everybody agree with me? Now, I know this still looks confusing. We have fractions in here. But notice our fractions have the same denominator, right? So I can add those. So I have 36 over square root of 3 plus 12 equals p. Now, going back to your Algebra 2 class or pre-calculus, you guys remember that we talked about, actually, we did some of this. We talked about this actually in this class. When you have your radical in the denominator, we have to rationalize the denominator. So to do that, I need to multiply by the square root of 3 on the top and bottom. So therefore, simplifying this, I get 36 square root of 3 over square root of 3 times square root of 3 is 3 squared, which is 3, plus 12 equals p. Then I can simplify this to 12 square root of 3 plus 12 equals p, or 12 times square root of 3 plus 1. But you guys can see in your answer that they leave it as the first one, which is letter J.